जय हिंद दोस्तों, माई सेल्फ इज निखिल कुमार, faculty of IT department in Ajay Kumar Engineering College. Today our lecture on the discrete structure and theory of logic, that the code is the BCS 303. It is especially for the BTech second year students, CS and allied branch, and the topic is the algebraic structure, special group features. In these slides, firstly we will discuss the last lectures, some measurements and some pros, some points that we have discussed in the last lectures, and then we will discuss the next something new one. Here in the slides and in the discrete structure especially, there are some terms that are especially used to represent some content, that is a n. Capital N is the natural number representation, where Z is the set of integers and Q is the rational number and R is the real number. Basically, these are the standard parameters that we will use especially for the to represent such numbers. But it is not the only thing that we will especially only use for these specific terms. We can use some, can be used can other one, but these are the standard one. The binary operation, specifically for the in the digital logic, the operator star is said to be a binary operation, closed operation on a non-empty set A if A star B belongs to A. That means binary operation belongs to a operation where at least there are specifically two elements are considered and n operations are applied on that. This is known as the binary operation. There are some properties that we want to be discussed earlier. What is the algebraic system? So algebraic system is a system which contains some features and some rules, regulations that are will be mentioned in the next slides. What is a commutative property? Commutative property is a structured in a algebraic structure specifically. If we apply a binary operation on a set value A, that is a non-empty set, in such a way A star B equal to B star A, where star is the binary operations. If such communication, such conclusion will be applicable, such property will execute and exist in such a way in algebraic structure, then we can say it is the commutative law. It is a property of the commutative law. In the case of associativity, A star B star C equal to A star B star C. Here firstly we will calculate this one, then after apply the result we apply the in such a manner, then here we will apply first one, this B star C, we will calculate the B star C, then after apply A star B star C we will calculate. In case of the identity element is the element that that will be the possible element in the non-empty set in such a way that for all the elements, for all the non-empty set that that is the exist in the algebraic system, that for all the system non-empty set, it is the unique value, it contains the unique value, and for all the in such a way that A star E equal to E star A equal to A. That means here E is the identity element and it is unique, contain the unique value for all the non-empty set that exist in the non-empty set in the algebraic system. In case of the inverse value, A star B equal to B star A equal to E. E is the identity element that will be unique for all the non-algebraic system set value, non-empty set. Here in this case A is the element and B will be the inverse for the element A. In non-empty set, specifically in the algebraic structure, for a particular element A, each element contains a inverse value that will be the unique for that element. So the next one is the semigroup. A semigroup is a algebraic structure A comma star is said to be a semigroup if it contains the property. First one is the closure property and second one is the associative property. What is the closure property? It is missing in the last slide. Closure property is such that if there is an non-empty set A contains some values that are the element, let's suppose that are the A, B, C. So and after and there is a binary operation star, it may be addition, multiplication, division and something else. Let's suppose it is algebraic binary operation plus. After execute the resultant value, let's suppose that value are the this one. All the value after apply the binary operation on the algebraic structure, if all the values are also exist in that the final conclusion term, then we can say it is the closure, that it is the closed operation on the set A. Okay. So that the semigroup contains the property, first one is the closure property and second one is the associative property. If both the properties are execute and satisfies the algebraic system, then we can say it is a semigroup. These are some examples. N comma plus is a semigroup, that means an algebraic structure that contains a non-empty set N, then it is the semigroup. What is the monoid? An algebraic structure A comma star is said to be a monoid if it contains the following condition or satisfy the following condition. First one is the closure property, second one is the associative property, and third one is the identity of element, that is the existence of the element. These properties are already discussed in the previous slide. This is the example that we have discussed, so that the closure property, associative property and identity property should be satisfied if an algebraic structure, then we can say that it is the monoid. What is the sub semigroup and sub monoid? So here sub represent the subset value, that means the semigroup contain a value, okay, that is satisfy the closure property and associative property in an algebraic structure. Then a term S comma star be a semigroup in that case where if T is closed under operation star, then T comma star is called a sub semigroup, that we already discussed. Sub monoid is also contains the same manners value. Let S comma star be a monoid with identity E. E contains the identity term. Basically, small e is represent for the identity element, and let T be a non-empty subset of S. If that means that T is the non-empty subset of S, then it is called the submonoid. If it is satisfies some property, that is the close under the operation star and E belongs to T. The very important topic, that is the group. So group is an algebraic system. G comma star is said to be a group if it follow some conditions. Okay, the first one is the closure property, second one is the associative property, then third one is the identity, existence of identity, and fourth one is the every element in G has the inverse value for the in the structure of the group. So if these four properties are satisfied in an algebraic system, then we can say that it is the group, where we can also use some terms when basically if the question is around the what is the group and what are the property. So it is the important one thing, but one more thing we should be add in that in the closure property, if we also mention that the term the element A, B also belongs to the algebraic structure G, that is the non-empty set G also, then after apply A star B also belongs to G. And it is also important to know and to clear that the E is the identity element. E is the identity element for the non-algebraic structure G. For the case of the associative operations, that A star B star C belongs to A star, it is nothing that only the firstly how to which order we will be execute firstly, that is the matter of concern. A star B firstly we will execute, then after apply the resultant we will apply on the element of C, the resultant will be the equal. There is an identity in G, that means the existence of the identity element in the algebraic structure, that means A star E equal to E star A equal to A. That means after apply the binary operations on the element A within the using of the identity element E, the resultant value will not be changed. That means the value A will be the same after apply the operation on the, with the using the identity element in the binary operations. The next one is the every element in G has the inverse in G. That means if A is the algebraic A is the element in the that belongs to the non-empty set and B is the, let's suppose B here, or we can say that if A inverse is the inverse element of the element A, then we can say A star A inverse strict A equal to E. That means after apply the operations, the resultant value will be the identity element. It is the criteria and the property. The next one is the abelian group. Abelian group is also a group. It contains some extra features regarding the that means the it also apply and follows the rules of the group. That means the four property also accessible in the abelian group, and one more property, that one is the commutative property. It is also mentioned in the abelian group. That means A star B equal to B star A, where A B belongs to G. A B also belongs to G. Should be belongs to G. It is the basic diagram for the algebraic system. That is the algebraic group, monoid, semigroup, and algebraic system. All this structure is belongs to the algebraic system. That is the contains all the features. Okay, semigroup contains some features, where monoid contain other one. Groups contains the four features. That one is the closure property, associative property, existence of identity, and inverse property. That contains the four property, where it contains the five property. That one commutative property is the extra one from the group. It contains the three property, and semigroup contains the two property, closure and associative. There is some theorem that regards the grouping. In group G, comma star, the following property hold good. That means identity element is unique for an algebraic structure. For a particular algebraic structure, it should be the unique value, and it contains the for the that means the non-empty set, it contains the uniquely. Inverse element of an element is unique. That means for a algebraic structure that belongs to that connect with a non-empty set and with the operations operated on that is the strict or star. For a particular element, the value of the inverse value is the unique one. The cancellation law hold good. That means what is the cancellation law? If A star B equal to A star C, then we can use that here A is common from the left side, that we can use and cancel out the A, and the resultant will be equal to C. It is the left cancellation rule. Left cancellation rule. But if we use the C is the from the right side, it is common, so the resultant will be A equal to B. Because C will be the cancel out, so we can say it is the right cancellation law. There are some other terms. A strict B inverse equal to can be write down B inverse strict A inverse. In a group, the identity element is its own inverse. That is also a very most important term. What is the order of a group? The number of elements in a group is called the order of group. That is the number of terms that are belongs to the algebraic structure. It is known as the order of a group. What is the finite group? The number of elements, if after apply the operations, binary operations in the algebraic structure, if the number of elements are limited and we can say it is the finite in nature, then we can say it is the finite group. In case the number of elements are not cannot in the finite nature, then sure it will be the infinite group. The next one is, so that the set of all integers in a group with respect to addition is abelian group. That means set of all integers in a group with respect to the addition is the abelian group. If we apply all the property, that means the actually we know that the abelian group contains the 5 properties. That is the closure one, associative, identity, inverse, and commutative. These 4 properties also contain in the group features, and this one is the extra features that are added in the abelian group. If we satisfy these properties, so we can say that it is the abelian group. From this example, we can prove that one, the set of all the integers in a group with respect to the addition. Actually, this is the binary operation that are used, basically used in the algebraic system, is the abelian group. The reason behind that is that the closure property, after apply the integers addition, also it will be the resultant will also be an integer's value, so that it is considered the closure property. Actually, here all integers are mentioned. If we only use the non-zero integers, that is the only positive integers is considered, then such scenario it will be changed. But here all integers in a group are mentioned, that the non-empty set contains the values all integers, that are the positive integers, and negative also contain the value 0. So all the addition, after apply the addition in the 2 integers, the resultant value will also be accessible. That is the integer value that a plus b belongs to z. The next one is the associativity, a plus b. That means the after the addition of 2 elements and the resultant after the resultant of that is addition is also added in the third one term, then the order, after apply the order change, the nothing will be changed, so the associative property will be executed. In case of the addition, the identity element belongs to 0. Identity element will be the 0, because after apply addition in the 0 term, nothing will be changed, the value will be remaining the same. So for the integers case, after apply the addition operations, in that particular case the identity element will be the 0. In case the inverse, every element we have minus a, that means every element have a inverse value, that will be the negative, because it is also mentioned that all integers are considered. So when we take a as a positive integers, then its inverse value will be the its negative, because after apply the operations the resultant value will be the 0, that are the identity element. It is also the property of the inverse. The commutative property also can be satisfied easily. So when we apply these satisfy these 5 terms, so we can say that it is the abelian group. This is the other one question where we use the multiplication. Here what will be changed? The identity element for that case will be the 1, because after apply the operations, binary operation on the non-zero real number, the identity element will be 1, because when we apply the multiplication on non-integer number, the resultant will not be changed, so the identity element will be 1. So it is a solution for that one. This is the other one. So that set of all real number R is not a group with respect to multiplication. Because here it is mentioned that not a group, R is not a group with respect to multiplication set of all real numbers. So 0 does not exist. The multiplicative inverse of 0 does not exist. Here R is not a group. For in the case where the multiplicative inverse, actually this is the term where we will collapse the properties, so we can say it is not a group. It is very important and very good question for the case of the monoid and for the case of the semi-group. Let's suppose that Z comma star be an algebraic structure where Z is the set of integers and the operation strict is defined by n comma m. Actually, this is the question I mentioned in this PPT belongs for a special term, that the algebraic structure containing a binary operation is not only consider the addition, multiplication and some other mathematical terms operative value, it can be considered the other one term, that is here if n and m are the two elements that are mentioned and are the element of the non-empty set, and after apply the operations strict, here strict contains the value that is the maximum, it represents the maximum value from that one. So we can use maximum of n and m from the n and m. So the closure property will be executed. That means from when we select the maximum value from two elements, so these value are also exist in the non-empty set. So this will be satisfy. In case of the associativity, it also be satisfied, because the after apply that change the order of the term from to calculate the maximum term from the three element, nothing will be changed. The element will be exist from one of from these three elements. From the case of the identity element, there is no integer x such that a star x equal to maximum of ax. That means we can not calculate the identity element from such scenario, because where we consider only two term and we will calculate the maximum from that one, so there will be more than one identity element can be count in such scenario, but that is not the property of the identity, existence of identity, because we already mentioned that the identity element in the algebraic structure is the unique value that contains the unique value. And it is also very important to tell you that the inverse element for a particular element in the algebraic structure contains the unique element. The next question is, so that all the set of all string S is a monoid under the operation concatenation of string. That means nothing will be changed. It will be considered as a monoid, because all the properties that belongs to the monoid, that is a closure, identity and associativity, is satisfied under such scenario. The next one is actually I will discuss some different type of questions. That one is an important one, or basically it is the part of an AKGEC previous year question paper. So the question is, so that the set of all positive rational numbers form an abelian group under the composition strict defined by a star b equal to ab upon 2. Here in that case, we firstly check out the closure property. When we take the all positive rational number, then apply such algebraic structure operation a star b equal to ab upon 2, then the resultant value will be exist in the non-empty set that satisfy the closure property. Second one is the associative property. The order will not be changed. the resultant value will be the same. So it associative property also satisfy. And next one is the identity element. Here the term A star E will contains the A E upon 2 according to the binary operation that are mentioned in the given question. So the resultant value from such manners will be the contain the equation 1. For the different one, that means the E star A, that means the EA upon 2 will contains the same value A. So from this one we calculate the identity element E equal to 2. That means the existence of identity element is the property of the group. So that the next one property is the inverse property. Here B is the inverse value of the element A. From the last one identity element we calculate the identity element 2. So here we use that one term A star B equal to B star A equal to E. Actually this is the property from the inverse law, where A is the element and B is basically the inverse value from the element A. This is the inverse value of the element A, and E is the identity element. Here in that case we use the E value from the previous identity element. So the resultant value of B will be, that is the AB upon 2. When we calculate this one, AB upon 2 will be the E2, so that the element B equal to 4 upon A. This term also exists in the non-empty set A, that is the existence of the inverse value. And commutative property also satisfy. Here A star B equal to B star A, because after apply the operations AB upon 2 and BA upon 2, the resultant value will not be changed after apply the change the order of that one. So the resultant will be the same. So we can say it is a abelian group. Prove that the identity element is unique. I already discussed that the identity element for a non-empty set in a algebraic structure in a group, it is the unique, contains the unique value. We can prove that if we take that E1 and E2 are two identity element, different identity element, and from this scenario and using this the identity element property, we satisfy that E1 equal to E2, so that the identity element will be the unique. The one of the main important question I will be discussed here. In case of 1 comma minus 1 is an abelian group under the multiplication. Here when we apply the two term element 1 and minus 1, after apply the operations under multiplication, the resultant value will be the 1 minus 1, 1 into minus 1 minus 1, minus 1, 1 minus 1, and minus 1 into minus 1, that is a 1. All the values that after apply the operations are exist in the set, non-empty set, that is the closure property as satisfy. Associative property will also be satisfied, because after apply the or change the order in different manner, the value will not be changed. The identity element basically in the multiplication case it is a 1, so it also exists. Inverse value we can check that for the case of 1, the inverse value is the, what is the inverse value? The inverse value is the same. We can check the inverse value is the same 1, and for the case of minus 1, the inverse value is the minus 1. For the commutative property also satisfied, because then nothing will be changed. 1 into minus 1 equal to minus 1 into 1, that is the minus 1 equal to minus 1. So all these 5 properties are satisfied. So we can say it is the abelian group. Thank you, class.